Dear student, good morning. Today we study about the chapter polymers. So we start now. Polymers. These are highly molecular mass substance consisting of large number of repeating structure units derived from simple molecules. In Greek language, poly means many and mer means unit or part. They contain macro size molecules and have very high molecular mass of order 10 to the power 3 to 10 to the power 7 U. They are also called macromolecules. The simple molecule which combine to give polymers are called monomer. The process by which the simple molecules, example monomers, are converted into polymers is called polymerization. Example polythene polymer obtained from ethylene monomer. You can see the display, the ethylene for the polymerization process convert into the polythene polymer. Student, keep this thing in your mind. Always be when you show the monomers, so small n put the left hand side just subscript, and when you show the polymer long chain, so you make a small bracket and strike with a line, and right hand side you put the n value, means these are the polymer and this is the monomer. Student, next point is homopolymer and copolymer. Homopolymer, a polymer formed from one type of monomer, is called homopolymer. Example, polythene is a homopolymer of ethene. Ethene is monomer. Above the reaction is shown again. Other example of homopolymer are polypropylene, polyvinyl chloride, polyisoprene, polyacrylonitrile, in a short dash pen, etc. A polymer formed from two or more different monomers is called copolymer. Example, or copolymer, second name is mixed polymer. Example, nylon 6,6. It is formed by the two types of monomers. First monomer is hexamethylene diamine and second monomer is adiapic acid. Some other example are guaians, polyesters, bakelite, melamine, formaldehyde, etc. In after session we can discuss about this. So on display you have seen the hexamethylene diamine and second one is the adiapic acid. The two different monomers, they form copolymer which is nylon 6,6. They consider is a copolymer because the monomers are not same, they are different. So student, the next topic is classification of polymers. These are divided into the three subparts. You can classify the polymers according to four categories. First one is classification based on source of availability. Second, classification based upon structure. Third one, classification based upon molecular forces. And fourth one is classification based upon mode of synthesis. So we can start the first topic, classification of polymers on the basis of source of availability. So student, the polymer can be broadly classified as natural polymers, synthetic polymers and semi-synthetic polymers. So first we discuss the natural polymers. The polymers obtained from natural plants and animals, example starch, cellulose, natural rubber, proteins, nucleic acid, etc. They are considered as natural polymers. Starch, you read in a chapter biomolecules, polymer of glucose. Cellulose also the polymer of glucose. Proteins are polymer of alpha amino acids. Nucleic acid are polymers of various nucleotides, example RNA and DNA. Natural rubber, polymer of unsaturated hydrocarbon 2-methyl 1,3-butadiene. You can see on the display. polymerization, they form the natural rubber. Student, second point is synthetic polymer. Polymer which are prepared in the laboratories, these are also called man-made polymer. Example, polyethylene, PVC, nylon, Teflon, bakelite, terylene, synthetic rubber, etc. Student, the third condition is semi-synthetic polymers. Polymers are mostly derived from natural occurring polymers by chemical modification. Example, cellulose on acetylation with acetic anhydride in the presence of sulfuric acid forms cellulose diacetate polymer. It is used in making threads and materials like films, glasses, etc. Vulcanized rubber used in making tires, gun cotton which is nitrate used in making explosive etc. Because they made by the natural and some modification they convert into the polymer, so they consider as a semi-synthetic polymer. Students, second category is classification of polymers on the basis of structure. These can be classified as linear polymer, branched chain polymers, cross-linked polymer. So first we take linear polymer. Polymers in which monomeric units are linked together to form long and linear chains, well packed, high densities, high tensile pulling strength, and high melting points. Example, high density polythene, polyvinyl chloride, nylon, polyester, etc. They are considered as linear polymer. Second is branched chain polymer. When a branch is formed, polymer in which the monomers are joined to form long chain side chains or branches of different lengths, irregularly packed, low tensile strength, low melting points than linear. Example, low density polythene, glycogen, starch, etc. They are considered as a branch chain polymer. Student, third type is cross-linked polymer. Polymer in which monomer units are cross-linked together form a three-dimensional network, hard, rigid, and brittle because of network structure. Example, bakelite, melamine, formaldehyde resin, etc. are known as cross-linked polymer. Student, other classification is classification of polymers on the basis of molecular forces. Depend upon the mechanical properties such as tensile strength, elasticity, toughness, etc. These mechanical properties depend upon intramolecular forces like van der Waals forces, hydrogen bond, and dipole-dipole interactions. Longer the chains of polymer, stronger is the effect of intramolecular forces. These are classified into four types. First one elastomers, second fibers, third thermoplastic, fourth the thermosetting polymers. So we take elastomers. The polymers in which the intramolecular forces of attraction between the polymer chains are the weakest and have elastic character like rubber. A material like rubber that can return by its original shape after stretching is said to be elastic or called elastomers. Due to the presence of weak forces, the polymers can be easily stretched by applying small stress and regains their original shape when the stress is removed. Student, on a display you have seen the vulcanization of rubber. In another segment we can discuss. First we take the second type, fibers. These are polymers which have strong intermolecular forces between the chains. These forces are either hydrogen bond or dipole-dipole interactions. Example, polyamide such as nylon. The intermolecular forces are such as orlon, acrylon, etc. Intermolecular forces are dipole-dipole interactions between polar carbonyl groups and between carbonyl group and cyano group. Because of strong forces, the chains are closely packed and thus impart crystalline nature. As a result, polymers have high tensile strength, less elasticity, sharp melting points, long, thin, and thread-like woven in fabrics. Example, nylon 66, terylene, silk, etc., they are considered as a fibers. Their forces are greater than elastomer. Student, third term point is thermoplastic. These are polymers in which easily soften rapidly when heated and hardened. When cooled with little change in the properties, the intermolecular forces, intermediate elastomers and fibers, there is no cross linking between the chains. Absence of cross link softening occurs as polymers chain move more and more freely when heated. Then they melt and forms fluid which can be molded into any desired shapes and then cooled to get the desired product. Example: polythene, polystyrene, polyvinyl chloride, Teflon, etc. They are considered as thermoplastic. Student, fourth category is thermosetting polymers. Polymers which undergo permanent changes on heating. They undergo extensive cross-linking between different polymer chains to give a three-dimensional network solid. As a result, they become hard and infusible. Therefore, they cannot be reused. Generally prepared from low molecular mass semi-fluid substance, the cross-links hold the molecules in which heating does not allow them to move freely. They are heavily branched molecule, permanently rigid. Example: bakelite, melamine. On display you can see the structure. Nylon is considered as a fiber, PVC is considered as a thermoplastic, and bakelite is considered as a thermosetting polymer. Student, last category of classification is classification of polymers on the basis of mode of synthesis. So first one is addition polymers. A polymer formed by direct addition of repeated monomers without the elimination of byproduct molecule is called addition polymers. The monomers, unsaturated compound, processes in double or triple bond. Addition polymers have some empirical formula as their monomers. Example: polythene or polypropylene, polyvinyl chloride. Only the one bond is break and they form the long chain. For example, ethene become into the polyethene polymer. Student, copolymer, the polymer made by addition of polymerization of two different monomers are called copolymers. But for example, bunais, bunine, etc. In an example, buta-1,3-diene mixed with styrene. So copolymerization process start and the form polymer is butadiene styrene. You can see on the display. Student, second category is condensation polymers. A polymer formed by the condensation of two or more than two monomers with the elimination of simple molecules like water, ammonia, hydrogen chloride, alcohol is called condensation polymer. Monomers generally have different bifunctional or trifunctional groups. Example: nylon 6,6 obtained by hexamethylene diamine and adiapic acid. You see on this display the hexamethylene diamine and adiapic acid on 525 Kelvin. So they will remove the water molecules. So they are considered as a condensation polymers. Another example are terylene, bakelite, alkyl, hydrogen, etc. Student, these are the different addition polymers and condensation polymers. In addition polymer, different monomers add to form a polymer having same molecular formula of the repeating structure unit as that of starting monomer. But in a condensation, a large number of monomers combine with the loss of simple molecules. Example: water, ammonia, hydrogen chloride, alcohol, to form a polymer having molecular formula of the repeating structure unit different than that of starting monomer. Second difference is nothing is lost during a polymerization in addition, but in a condensation, small molecule like H2O, NH3, HCl, ROH are lost. Third, In addition, generally involves are monomer. In condensation involves two monomer. Fourth, the monomers are generally unsaturated compound but involves two monomer. The monomer generally contain two functional group. These are examples: